Are you ready to move your AI model from a promising idea to a scalable reality? Lots of teams get stuck in the challenging transition from a successful prototype to a production-ready system. Hi, I'm Michael McNeil.
And I'm Kevin Collins. We're black belts at Red Hat. Think of us as technical experts who help customers solve their most complex challenges and get the most out of Red Hat cloud services. Today, we're discussing how organizations can take advantage of Red Hat OpenShift Dedicated on Google Cloud, a comprehensive application platform to run your AI workloads. Let's go see what this looks like on the board.
So Kevin, that all sounds great. How do we get started with OpenShift in Google Cloud?
So with OpenShift Dedicated on Google Cloud, you can quickly build, deploy, and scale your AI-enabled applications with the built-in security features and trust you expect from Red Hat and the scale you depend on from Google Cloud. So let's talk about what it takes to get started. So on our Google Cloud project, we're going to start with a VPC, a really big VPC, and it's going to have 3 subnets in the VPC. So here's our VPC. We're going to have 3 subnets, one for Private Service Connect, another one for our control plane, and a last one for our worker nodes.
So this Private Service Connect subnet, what exactly is it used for?
So with OpenShift Dedicated on Google Cloud, it's a managed service. So Red Hat S3s are going to be managing the cluster, making sure it's running optimally and providing you 24/7 premium support. Now, in order to connect into the cluster to monitor, make sure it's running optimally, we're going to connect a Red Hat account here through a Private Service Connect. And we're going to have a Private Service Connect attachment. And this is a secure way of connecting Red Hat to your customer environment where the cluster is running.
Got it. So that way it doesn't go over the internet or anything like that.
Exactly.
Got it. That makes sense.
So, Michael, now that we have kind of the networking in place, we have our VPC, we have the connection from Red Hat into our account. What does the compute look like? How do we actually run workloads in this cluster?
Yeah, absolutely. So compute is broken up into these things that we call machine pools. And so by default, you have the control plane that lives in this account. So you've got 3 control plane instances, and those all that kind of live as the brain of the cluster, right? And so beyond that, then we have 2 different sets of default machine pools. The first is called infrastructure nodes. So you can have 2 or 3 of those. And then on top of that, you have what we refer to as the default machine pool. And so that default machine pool is great for things like running the OpenShift core components, things like the default applications and workloads that are really general purpose focused. So in those, we'll call them just workers. Now, when we talk about how you actually deploy AI type workloads on that, you generally need GPUs. And so for us to do that, we'll create another separate machine pool. These will be GPU machine pools. And as we do that, right, we can create all of these together inside of our cluster, and we can run workloads specifically on those GPU nodes.
Great. So for our AI applications, do we require GPUs, or is there something else in Google Cloud we might be able to leverage?
Yeah, so GPUs can get really expensive. And so it's a great thing to do to take GPUs where you need to actually utilize those GPUs. Google has a great selection of a bunch of different GPU instance types that you can use with OpenShift Dedicated, but then supplement those with things like a high memory instance type. So those high memory instance types, we can deploy a separate machine pool, and those can be used to supplement those for resources that don't necessarily need GPU cycles. Maybe they just need memory intensive compute. And so we can tie all of those pieces together to ensure that we can actually utilize them effectively and be the most cost efficient in our operational model. Now, when we talk about this though, Kevin, how do we actually make sure that OpenShift Dedicated can use the GPUs for the workloads on the platform?
Yeah, great question. So part of an application platform we have with OpenShift Dedicated on Google Cloud, we have the concept of operators. So operators are going to allow us to add additional software components that the application platform provides to provide those additional capabilities. One of those is to recognize the NVIDIA GPUs. So control box for NVIDIA GPUs, and there's 2 we're going to talk about. First one is NFD operator, which is the node feature discovery operator. And what this operator does, it comes from Red Hat. It's going to scan the nodes that we add to the cluster, like the GPUs, and it's going to look for unique hardware characteristics of that node. So first step, we recognize, yes, we do have a GPU on the cluster. And the next step is we're going to add an NVIDIA operator itself. This has all the software components required to take advantage of that GPU that NVIDIA provides.
Awesome. That makes a lot of sense. So then when we talk about this, how do we make sure that those resources can actually use those workloads? Like so the node feature discovery, what is it actually going to do? It's going to scan them, and then how does it know to put the NVIDIA workload there?
It's going to scan the labels, and your workloads that you put onto the cluster will have a label that will match with the node in the cluster.
Oh, awesome. That way you can make sure that they go to where you expect them to.
Exactly. So, Michael, now we're taking advantage of the NVIDIA GPUs. Where does Red Hat OpenShift AI come into the picture?
It's a great question. So OpenShift AI is an add-on on top of OpenShift, and it's very similar to the operators that you described here. It's just yet another operator inside of the environment. I'll draw another box here. And when we kind of think of these operators, there are a few things that OpenShift AI pulls out of the greater OpenShift application platform that are really important. The first is what we call OpenShift Serverless. OpenShift Serverless is based on the Knative Upstream project. And so that's an open source project that's widely known and used for Kubernetes serverless eventing and serving of those resources. It's really important in an AI ecosystem because ultimately when we're talking about serving resources, we want to use them in a way that is specifically done through that eventing model. So beyond that, then we have Service Mesh. Service Mesh is really neat. It's a part of OpenShift that's really important because what it does is it takes things away from the plate of your data scientists. Your data scientists are focused on building the underlying models that they're using. They're training the models. They're doing all of that associated AI work. And they don't want to be worried about how do I secure connecting those resources together. They don't want to worry about all of those pieces. And so Service Mesh can move that to the responsibility of the platform operations team and instead allow your developers to simply just start utilizing the benefits of that platform. And then last is an optional piece. And this is an AI specific piece, but it's called Authorino. Authorino is used to secure models, right? So it's to secure and ensure that the associated like role-based access control and things like that around OpenShift is able to apply to the actual AI components as well. Now, when we get on top of this, OpenShift AI actually runs just like another one of these models. And so you just deploy OpenShift AI. Just like another operator. And so as we do that, we essentially get to a model where we can then begin using all of these components that are part of the OpenShift ecosystem. And we can use that as a way to actually deliver AI applications, both generative and predictive AI, in a faster way for our customers.
That's great. So now that we have OpenShift AI on the cluster, we have all those supporting operators you talked about. Now we can start leveraging this MLOps platform to build and generate our generative AI applications.
Exactly. So when we actually picture this kind of together, what does this look like with other tools like, say, Google Vertex AI, for example?
Yeah, let's take a look. Let's erase what we have and we'll look at what that looks like. So Michael, OpenShift Dedicated on Google Cloud allows you to integrate with hundreds of different developer-based tools and many AI platforms. Now, to picture how this is going to work together, let's think of a traditional DevOps workflow that's very familiar to a lot of us. In a traditional DevOps workflow, we're going to have steps for coding, building the application, doing QA and review. We're going to deploy the application, we're going to operate it, run it, and then monitor it, and that cycle will continue. Now, we start talking about machine learning ops or the MLOps workflow. It's very similar, but now we have the additional layer of complexity as we have to take in consideration data and models. So let's start by thinking of the outer loop of the MLOps workflow. So OpenShift AI is going to streamline the outer loop process of the MLOps workflow by covering the entire lifecycle of your machine learning models. So we're going to have a similar workflow here. We're going to have steps for reviewing our models. We're going to build the models. Then we will deploy them. Then we'll serve the models using OpenShift Serverless that you talked about. And then finally, we're going to monitor the models. And this is the outer loop that will continue making our application stronger.
Yeah.
So how would this work with Google Vertex in the inner loop process?
Yeah, absolutely. So when we actually think about that, Google Vertex AI is really part of that inner loop process. And so it allows you to kind of do the experimentation and things with those foundational models that are really important for developers to use and tune to their individual specifications. So we'll draw another loop here. We'll call this the inner loop. Now, with the inner loop, we've got kind of a similar model, right? So we're going to start by gathering our data. And so that's really important because ultimately, like data scientists, that's their focus, right? They're going to gather the data. Once they do that, they're going to actually prepare that data, right? So they need to get that data in a way that they can then actually begin to utilize inside of their models to train them. And that's the next step, right? We take that data and we use them to actually train our models and ensure that they're giving us the results that we need. As a part of that, we're going to run a continuous set of experiments. So experimenting is really important when we go through this because ultimately this process, just like the outer loop is ultimately a cycle that we're going to continue to work through to actually build and fine tune our models. And so once we do that, we kind of gather, prepare, train, experiment, then we're going to actually begin our tests. And so the testing is kind of that stage where we're going through, we're taking the data and we're seeing if it actually behaves in the way that we expect it to. We can do that using a bunch of different foundational models that Vertex provides.
That's great. So then the inner loop is going to feed the outer loop. And then we'll continue the outer loop, which will feed the inner loop, making the whole MLOps process stronger, building our generative AI applications.
Exactly.
So, Michael, I know a lot of our customers are also leveraging IBM Watsonx. How would that fit into this picture?
Yeah, absolutely. So one of the great things about IBM Watsonx is that it provides a platform on top of OpenShift AI that you can actually use to interact with tools like Vertex AI. And so when customers are actually using IBM Watsonx, they're doing it generally for things like governance, for example, right? They're wanting to implement additional governance around the models that they're actually using to ensure that they're behaving in ways that support their organizational requirements, making sure that it supports their business needs. Ultimately, it empowers developers to take these tools that OpenShift provides and use them even further.
That's great. So by combining the capabilities we have with Red Hat OpenShift AI, with Google Vertex and IBM Watsonx in a single application platform, we get a strong MLOps platform for building in these generative AI applications.
And this all brings us back to our original question. How do you take your AI models from a promising idea to a scalable reality? The answer is a platform that simplifies the entire MLOps lifecycle.
By providing a standardized automated environment and the flexibility to use platforms like OpenShift AI, Vertex AI, and IBM Watsonx, OpenShift Dedicated on Google Cloud gives you the tools, consistency, and confidence to navigate your transition. Now get your AI projects out of the lab and into production. Click the links to learn more.